Hi, today we're going to talk about individual motor circuits and a bunch of code rules that apply to them. As you can see, I have a drawing over here. I got 10 rules that we're going to be talking about. And I have my motor branch circuit here, fed off a splitter. You can see the devices. I have a disconnect, overcurrent, magnetic motor starter with a start-stop switch, and then my motor down here. Now the nameplate data here, we have a 200-volt motor. It's three-phase. It's a 10-horsepower motor. It's continuous duty. It's a drip-proof, and the service factor is 1.15. So we'll utilize all that information as we go along. So the first step into figuring out all of this stuff is the FLA. That's so important. And I don't actually give it to you here. I just say it's a 10-horsepower motor. So table 44 is where we figure that out. And table 44 for the 200-volt three-phase motor says it's 32.2 amps. That is the FLA. And that's, like I say, so important. All right, now we're going to size the wire that's connected to this motor. And that wire size is going to be spun off of 28106. And what we need to know is what kind of duty this motor is. So we said it was a continuous duty motor, and if we look at the rules, basically we take the FLA, multiply it by 1.25. So FLA by 1.25. So we get 32.2 times 1.25. Do the math and you get 40.25 amps. So that is the minimum ampacity that the wire can handle. Now we go to table 2, and table 2 says we can get a number 8 wire on that at 50 amps. The other thing I forgot to mention is this is all 75-degree temperature rated equipment. Make it easy on us. Okay, rule number 3 is just this wire that supplies the motor also has an insulation rating on it. And that is from 28104, tells us about insulation rating. And that actually sends us to table 37. Now, I'm going to give you a class on this motor. We'll say it's a class B motor. And if you look at class B in table 37, it says the wire insulation has to be at least 75 degrees. So you can use still RW90 if you want, but the minimum temperature that that wire can be for a Class B motor is 75 degrees. Now I'm going to skip up to 4 here, which is pointing at the control device or the magnetic motor starter. And that is 28500, which basically says we need some kind of control for a motor. And sub-rule 1 basically says that has to be horsepower rated, the same as the motor or higher. So we have a 10 horsepower motor, so then this has to be a 10 horsepower starter. Now for those that are into NEMA sizes, that would be a NEMA 2 motor starter. Now we're moving on to the overloads. So the overload heaters in this case, and that is 28306. And there's some rules to read there. What's important is the service factor and the FLA. So basically, the rule says we take the FLA and multiply it by the service factor multiplier. Now, the multiplier is not always the same as the service factor. So in this case, it's 32.2 times the service factor multiplier, which the rule says if it's the service factor is 1.15, the multiplier is 1.25. So you do the math on that, 32.2 times 1.25, you get about 40 and a quarter, 40.25. So that's the maximum that we can set the overload device here. Now sometimes you can't adjust them, you just have to buy them. So maybe I'd buy a 40 amp overload device and that would be good enough. Okay, moving up here, 6, 7, and 8 are all pointing at the disconnect switch here. So step 6 or rule 6 here is just talking about we do need a disconnect. So that's 28-600 that says, yes, we need to disconnect the motor starter, and the branch circuit. So 28-600 just outlines that. Now, step 7 is actually the type and size. Now, there's different ways or different types of disconnect devices. I chose a switch here. So 28602 gives us our options for the disconnects. And I chose item or subrule 1, item B, which is a switch, which complies with 14-010, which basically says that switch has to open up all the ungrounded conductors or all the hot conductors, which makes sense. And it also talks about the minimum ampacity of the switch has to be 115% of the FLA. If you do the math on that, that's going to give us around 37 amps. This is minimum. But when we start sizing this overcurrent device, which is a part of this process, we won't have to worry about that. We only have to worry about the size of that rule if this is an isolated switch on its own. But we're not doing that here. So let's move on. Step 8 is step 8, we're just looking at the size of, or the location of this disconnect switch. Where can it be located? So that's 28604. And if you look at subrule 1B, it sends us off to subrule 3, which basically says within sight and within 9 meters of the motor and all the equipment that it's, like the load. So we can either do this, put this, the location of this disconnects so we can see it from the motor, and within 9 meters. Or if that isn't possible, we can make it so it's lockable, and then we have to label it too with the motor. So that's our options there from 28604. Now, getting squeezed out by the print here. Number 9 points to the overcurrent device, so that's 28200. And sizing the overcurrent, that will send us off to, and I'm just going to branch it out over here, table 29. And this is an important table for us. Now, what we need to size our overcurrent device is if it's a fuse or a circuit breaker. So I have a fuse drawn here, and it's going to be a non-time delay fuse. So we need to know if it's what type of fuse it is, and also what kind of starting. I have a magnetic motor starter here. It's straight up, so this is full voltage starting. It's a 3-phase system, non-time delay fuse. When you look at that in table 29, it basically says the overcurrent is 300%. So if we do 32.2 times 3, we get 96.6 amps. That's the math. That's the maximum that overcurrent device can be, which means in reality, we're going to buy a 90 amp fuse in this case. And then step 10 is talking about the taps. Now, motors have a special rule for taps, and that's 28, 110, and subrule 2. And it basically says that this tap has to be the same size as the feeder, but there's an exception. If it's short enough, in other words, the rule says within 3 meters, let's say that this tap is 2 meters long, then what it says, if it's 2 meters long, we can basically size the wire like we did down here in 28106. And at 28106, that gives us, in this case, a number 8. See you next time.